So this is going to be a beginner level talk, and I'd like to introduce a new library that Google recently released to train tree-based models. And these are things like random forests and simple decision trees and gradient boosted trees as part of TensorFlow. And the reason you might be interested in this, even if you've been working with trees for a while, is that you can save these models and you can serve them using TensorFlow serving and things on GCP exactly like you would save and serve a TensorFlow model. So it's a great way to deploy trees into production using your existing infrastructure. Basically, so just a little bit of background. So I got started in machine learning way back in 2004 using simple decision trees. And I absolutely loved them for a very long time for reasons that we most likely share. So, for example, things like a decision tree and even a random forest, it's a type of model that you can visualize and understand. You can display the tree, and I'll show you how to do that in code, and you can look at it and you can think it through. The other nice thing about tree-based models is, as you know, they map very closely to business problems. So when we think about business logic, we're often thinking in terms of a tree. And also, as you know, most data in business is structured data or tabular. It's data that you would find. Oh, I'm sorry, I can hear myself, but let me see if I can mute the other tab. All right, cool. It's data that you would find often inside a spreadsheet. And when you have spreadsheet data, the truth is, as amazing as neural networks are, usually a winning solution on a Kaggle competition is something like a random forest or a gradient boosted tree. So these models, even though they're a little bit older, much older than neural networks, they still succeed in practice, especially for the everyday, simpler types of business problems that are actually incredibly important because they often affect revenue. Anyway, neural networks are amazing. Trees are still incredibly important. We use them in production at Google all the time, and it's a great library. So let me see if I can switch over and just show you just a couple slides, and then I'll dive into code. So the library is called TensorFlow Decision Forests. It's currently in beta in open source, and the easiest way for you to get started with it is to follow this link. So what I did is, and you can open this up now if you like, or you can open up later and I'll walk you through it. What I did is I wrote a tutorial for you. It's based on one that I wrote on the website, just has a little bit more detail. And I added a very short programming exercise that you can try at home if you like, after the talk or whenever, just to get started. And it's relatively straightforward, and I think you'll like it. And excuse me, the library also has a bunch of options for advanced users. So it's bit.ly/GDG TFDF, and that stands for TensorFlow Decision Forests. And while you're opening that up, I just wanted to speak briefly about what's new in machine learning. And I just wanted to also speak to a question I get a lot. If I'd like to get involved in machine learning research, what's a good way to do that? So two extremely cool things that were recently released from Google, which you've almost certainly heard about already in this conference. So I'll be very quick. A image generation model called Imagen or Imagine, and a text generation model called Palm. And I just wanted to mention that it's important in machine learning as the field expands incredibly rapidly. These, of course, are both based on neural networks. It's important in machine learning to stay objective and not to be too personally invested in any one technique. So, for example, I loved trees and I still do. But in 2012, it was super clear to me that neural networks were the way forward for many different types of problems. So I switched over to them and I began working later on TensorFlow. And likewise, um, even today, when you have a business problem or you need to understand exactly how your model is working, trees are often the best solution for you to use. And so I think I've seen like some silly arguments on Twitter and stuff like that where people are going back and forth about which technique is better. And it's just important to remain objective and not too personally invested in any one particular approach. We're all trying to move the field forward and use the best tools for the job. Anyway, deep learning is doing amazing things. So in terms of research that you might want to do, some people look at things like this and are often intimidated. This is super large scale research. It often uses some math and like new types of very complicated techniques. But there's another, so this kind of falls into the bucket of large scale or pure machine learning research. There's another bucket of research that you can use, which falls into the category of applied machine learning. And this is a very old paper from Lily Peng's group. I think it's about 7 years old now. But the TLDR, and you've probably heard of this before, this was the original paper in diabetic retinopathy, where her group applied machine learning to a problem in healthcare. And if you look at this, this is a screenshot of the JAMA homepage. It's the Journal of the American Medical Association. And her paper was the most heavily cited paper in the last 3 years in this medical journal. And what's really special about this paper is it was really thoughtful work on the healthcare side of applying machine learning to a new and important problem. But it didn't involve a lot of fundamental work in machine learning itself. So there was no new algorithm, no new gradient descent optimizer. It was applying largely off-the-shelf techniques to a really important problem. And Google is still doing new work in this area. So this was a very recent paper from a few months ago, and it's on the Google AI blog. It's detecting signs of disease from external images of the eye. And what was really special about this paper is instead of just classifying eye disease, they asked a really thoughtful question, which was, given just a photograph of your eye, what other things can we predict about your health? And one thing they were able to determine is that you can predict, with some margin of error, somebody's risk of diabetes or perhaps their blood pressure. And what's really great about this is it's an application of ML to develop potentially non-invasive tests. And again, what's really special about this, it's using largely off-the-shelf software to do cool new things. So basically, if you're new to machine learning research or you'd like to get involved, I think the best advice I have for you would be find a field that you're passionate about. It could be healthcare, astronomy, it could be zoology, whatever. And then see if you can use existing machine learning techniques in some way to help that field. And often that can be the most impactful way to get started. And the barrier to entry can often be lower than the super scale work, which can be intimidating and is not always the way to get started. Anyway, that's just quick words about the field in general. So going back to decision forests, I'd like to just quickly walk you through, and I won't read this notebook for you. I wrote it for you to try out, not to chill and have me read it. But the Bitly link should go directly to this notebook for you. And basically, it's if you're interested or if you're in industry and you're curious about why maybe you should still be using decision forests in 2022, I linked to a survey from Kaggle. And this is the state of data science and machine learning. And basically, they've got a lot of really cool stats on here. It's worth flipping through and reading. Let me see if I can pull up some slides for you. It's pretty cool. Ooh, the order has changed. Hang on just one sec. Anyway, you can see the different types of algorithms that are popular, different types of educational backgrounds. I believe there might even be some stuff in here on compensation. But if you look at the most popular algorithms on Kaggle, and this is from 2021, you have things like linear and logistic regression, and right off the bat, you have decision forest type models. And so they're still extremely valuable for you to learn. Anyway, so let's get started. So this library was designed to be easy to use, and this is the general flow of the code for training a decision forest model, and that's a term that encompasses all tree-based models. Basically, it's a TensorFlow library that you can install in Colab. It plays nicely with pandas, which is good news. And the basic idea is that you can start directly from a CSV file. And then we have a utility that will, in a one-liner, and this is great, convert your pandas data frame to a TensorFlow data set. And the truth is, well, this is necessary so the library can ingest your data. And the truth is, for small data sets that fit into memory, this doesn't add a huge amount of value. But the library also supports distributed training. And TF data, it's a little bit complicated to use, but it's a higher performance data loading library that becomes important when you're working with enormous data sets. From there, you can instantiate a model. And like scikit-learn, the models have good defaults. And I'll show you later, they're customizable. You can adjust all sorts of stuff. you can train the model, oh dear, and you can display some stats about it. So let's take a look at how this works in practice. So you can install TensorFlow Decision Forests in Colab or whatever environment you like. It's not included in Colab by default yet, but we hope it will be down the road. And it plays, works with TensorFlow. And what we're doing in this tutorial, and this is largely one that I wrote on the website, but we're downloading the Palmer penguins dataset. And this is just a simple CSV file. And basically, the goal is to determine what species of penguin we have based on different just attributes, like the island the penguin's from and different features about the size of the bill and whatnot. What's really nice is one advantage of tree-based models is, unlike neural networks, there's very little pre-processing you have to do about on the data. So trees, they naturally handle numeric and categorical attributes. You don't have to worry about one-hot encoding. You don't need to worry about normalizing your numeric attributes. It will be just fine. And so they're very easy to get started with. And what's nice, in addition to being user-friendly, they're also relatively hard. They're harder to get wrong because they're less sensitive to pre-processing. And we just have some little code here working with pandas just to split the data set into train and test. And here I just wanted to show you, we have these little one-liners that will give you TensorFlow data sets. And what's nice, there's a couple different models that are available inside TFDF. So simple decision trees, random forests, gradient boosted trees, and a distributed gradient boosted tree, which should now be working in open source, which is great. For advanced users, if you've been working with these things for a long time, and you're like, well, why should I, try this library out? I'm already happy with another one you might be using. And by the way, that's great. There are so many amazing libraries for working with tree-based models. There's XGBoost, there's scikit-learn, and there's others. The primary reason to use TensorFlow Decision Forests is not to compete with these libraries. They're excellent. It's if you're already in the TensorFlow ecosystem or you would like to serve it, or if you would like to play with a couple recent papers. So what I'm showing you here, this is the help on the decision forest model. And if you flip through this, you will see a huge number of parameters you can configure for exactly how the forest is grown. And some of these are from recent papers. There is a lot of powerful stuff. So I've been working with trees for a while, and I thought I knew a lot of things until I met the team that was writing this library. And it's amazing. So this is a lot to keep you busy for a very long time. Anyway, what we'll do is there's different batches of predefined hyperparameters you can use. And these are models, and I really like this too. The team put some thought into this. So they're typically better than the default parameters you might find in the paper or other libraries without being more expensive. And what the team did is they just ran a bunch of benchmarks on data sets that they had sitting around, and they found a nice balance of performance and accuracy for you to use. So there's different benchmarks, and this was a good performing batch. Anyway, so it's very cool. Anyway, we can get the model set up. And training it, as you would expect with most other libraries, is just a single line of code. And basically, this is beta release. We're working on suppressing some of these warnings for you and fixing them. Basically, there's some complaints here about autograph not initially being able to compile the code, but you can ignore that. It actually does work. That's a false mistake that we're working on. And then we wrote a little utility that lets you visualize the tree in Colab. And so this is nice and interactive, and it's just a great way to display the tree. And you can flip through and you can read the decisions and see which attributes were important, and you can follow an item as it's being classified. You can display different trees from the forests. The library lets you evaluate the model on OOB data. And basically, this is data that is, the out-of-bag data is data that was not selected for training the trees when you were selecting random subsets of the data in the forest. And what's nice is this is just a little example of how you can see the accuracy of the forest as a function of the number of trees in the forest. And this is a nice thing about, by the way, I know I might be moving a little quickly, so I guess this is more of, rather than a beginner-focused talk, this is more of a quick overview of the library and a code example for folks who already are familiar with decision forests. But anyway, one nice thing I like about random forests and why I was attracted to them initially is sometimes they're a little bit harder to get wrong than neural networks. So they might not be the most accurate possible model available, but they tend to do well in practice and they're hard to be the worst. So basically, number of trees is a nice parameter where often if you set that too high, you won't hurt your model. The worst case is it will just take a little bit longer to train, which is a really nice property. I like that a lot. Anyway, you can evaluate it on your test data set, and then there's different variable importances that are available in the library. So you can evaluate how important were different features, basically based on where and how often they appeared in the tree. Um, and you can use this to dig through just different features in the data set. So with this particular importance measure, it turns out the length of a flipper was the most important attribute for determining the type of penguin. And then there's just some common questions here, which we meant to add to our tutorials, but we forgot. I just wanted to add some example code for you so you don't have to figure this out yourself of how you can make a prediction on a single example. And so here's just a little Python dictionary that we're just quickly converting to a data frame and then to a data set, and then you can make an example. And likewise, you don't have to debug this yourself. I also just wrote some code that you can use to make predictions on many examples. And following that, there's an exercise that you can try, and it's using the census data set. And to be honest, this is a data set we're trying to move away from. It's I'll show you it right now, and I'll show you it using a tool called Facets. So the census data set, it's from the 1990 US Census, and it's loaded by default into this tool you might like called Facets. You can find Facets at this link, pair-code.github.io/facets. And Facets, it's basically a CSV visualizer. This has nothing to do with TensorFlow Decision Forests. It's just a tool that Google released to help you visualize and explore CSV files. What's nice is it has the census data set from this example loaded by default. So it has exactly the same data set that this example will download. And I just want to show you how you can use this tool to visualize the data set. And by the way, we're trying to move away from this data set. It's often used as a teaching example when we're dealing with things like responsible AI. But the goal of this data set is to predict whether or not somebody makes more than $50,000 in 1990 in the United States based on attributes like what their educational background is or what their profession is. So it's not an ideal data set, but it is good for teaching purposes. And let me see if I can show you what Facets is. Oh, it's not working too well right now. That's strange. Hang on one sec. Why is... okay, that was my mistake. So what we're looking at here, what I've done is every dot on the screen corresponds to a row, and there's a link to Facets in the notebook as well, corresponds to a row. Let me just show you this spreadsheet. So this is a subset of the 1990 census. And you can see, for example, in the CSV, this person's 39. They work for a state or government. They have a bachelor's degree. I believe this 13, although we'd have to check the header, corresponds, which is missing. So I wrote the header here for you. Might correspond to the years of education they've had. They were never married, blah, 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 blah. Unfortunately, it has race and stuff like that in it as well. And they make less than $50,000. So that row would correspond to some dot on this spreadsheet. So if I click on a dot, you can see attributes about this person. And each dot maps to a row in the CSV, which is really cool. And in Facets, that's another word for basically bucket. So it's a good way to become familiar with the data. So what I've done is I've bucketed the data, in this case by age. And here it looks like blue means they make less than $50,000, and red means they make more. And already, if you have a new spreadsheet or a new CSV file, you can gain some insight about the data. So, it looks like young people, 18 to 26, in this data set, it was very unlikely that they were high earners. Whereas, people in their 40s and 50s were much more likely to make more money. And what's cool, is you can facet by multiple attributes at once. So here we can bin it by age. And then we might also want to take a look based on their educational background. And so now we can take a look at, if you scroll through this, and you find some buckets that are very red, so many of these people are high earners. You can see these are their people in their mid 40s um, with a bachelor's degree. And if you look at this bucket, is almost all red. These are professional school people. So these might be lawyers or doctors or something like that. Anyway, it's a really nice way to get to know your data. And there's another tool that you might find valuable that's also built into Facets. And this is the one that's a little bit more boring, but like a lot of things in life, it's also very useful. Basically, it just gives you some summary stats on the data set. So for each attribute, it will give you things like the mean, the max, the standard deviation, and it will also flag things with missing values. And it will flag things that have lots and lots of zeros, because often a zero can be indicative of missing value. So it's just a nice way to like check out your data set. So Facets, it's really cool. I like it. It can be good for teaching purposes, and you might want to check it out. Anyway, what the exercise does is it basically downloads the Facets dataset for you as a CSV file. I added a header for you, and then it basically has just some like EDA just to check out some stats on the data set. And then it has some very simple code that you can follow that walks you through basically, given that you have this CSV file, how do you go ahead and train a gradient boosted tree using that file, and how do you evaluate your model? And it has a little solution that you can try at the end. And then if you're interested in using a more real world data set, our friends at Kaggle also just published some starter code for you last month. And this is on the the Kaggle Tabular Playground series. And this is a data set with 1.7 million examples that you can use to train a more serious model and really see what this library can do. I think there's like 900,000 in train and 600,000 in test, or something like that. So there's a real world data set you can play with at the end. Anyway, the TLDR of the talk, basically, we have a really nice website where we've begun publishing bunch of tutorials and guides and API references. So you can find more examples here, including how you serve it, including how you do distributed training. And then there's also some advanced tutorials that show you how to train ensembles of using neural networks and decision forests together. There's a lot of cool stuff. So basically, check out TensorFlow Decision Forests on the website. There's a link to the Kaggle tabular playground dataset at the end of the tutorial. And you can find a code example and exercise that I wrote for you at bit.ly/GDG/TF So yeah, thanks very much. I wish I could see you all in person. It's always kind of tough to give talks over Google Meet or Zoom, when you can't see everybody. It's just what we've been dealing with for 2 years. But um, I hope this library is useful to you. And yeah, enjoy. I'm happy to answer any questions.
Hey Josh, thank you so much for your speech. It was very interesting. And we do have some questions in chat too. But also, I think a lot of people from got a lot of like collab notebooks and tutorials from today's speeches. So I think maybe if you want to, after our last speech keynote, you can just go ahead and run through all of the code our speakers shared. I think it's like the most you can learn is when you go straight into it and run the code yourself and see how it works. So let me go straight to my the first question, which I'm not sure. It could be technical, but maybe it depends on what sense. So the question is, what is your favorite tree?
That's a great. Oh, by the way, one more thing. So as a life lesson, you should never promise things before they're ready. But we're working on a very short mini course to help developers learn more about random forest and gradient boosted trees. It's like 80% done. We just haven't published it yet because we're just polishing it. But hopefully in the next few months, we'll have a course that you can take. Um, I
That's
think my favorite
amazing.
tree is any tree that I can visualize. So basically, when I took my first machine learning class almost 20 years ago, I was totally confused. Basically, the professor he was a really nice guy, but he just put so much math on the blackboard. I didn't know what was happening. I didn't even know what machine learning was. And then finally, a different professor showed me a decision tree. And I was like, oh, now I understand. And so I like trees because I can see them. So
Yeah.
any model that you can print out and see because you can understand it.
Well, amazing answer. Thank you. So our next question is from Vera, and she's asking if you could tell a little bit about the next milestones for TFDF before reaching 1.0.0, please. So, what are your
That's an
next
excellent
milestones?
thank you. Thank you for the question. That's an excellent question. I don't It's a very small engineering team, and I don't wanna speak for them. I'm just a user and a fan of this library. I'm not actively writing it. The milestones that we've talked about together are mostly just polish. And so, for example, there was that warning about autograph in the tutorial, and that's not something that is there's no action there. I think it's basically just we're just cleaning up things like that. My goal is to make the library really easy to use and as simple as possible. So it's just polished like that.
Awesome. Thank you, Vera. If you have more questions, please do write in chat. So the next question is, what library API except the forest do you find handy?
So I like simple decision trees. So what I always do with tree-based models, and like you can use neural networks for structured data too. So I'll show you. Um, so this was a tutorial that I think an intern uh, who was much smarter than me wrote. But basically, on TensorFlow.org, we have a really nice tutorial that will show you how to classify basically spreadsheets and tabular data and CSV files using neural networks and using Keras. And this is really cool. It can be very, very powerful, but it takes more code, and that's just a feature of how neural networks work. So what I always do before training a neural network on structured data is I train a simple decision tree first, not even a fancy one, just a basic tree, just for a strong baseline. And the truth is, even a single decision tree will give you strong enough accuracy that you might have to work a little bit to do better with your neural network. And so it gives you a simple baseline just to make sure things are going okay. And
Yeah.
then for folks that, if you really want to get more advanced or higher accuracy, usually gradient boosted trees are the way to go.
Well, I can hear that you're a big tree fan, and I can understand that honestly from like the stats you showed from Kaggle with the like linear models being the first most popular model and the trees being the second. I think that's very understandable, and it's a good thing to start from something that works and something that is simple, and also like the big cool thing about the trees is that they are explainable. So, can you tell maybe from your experience about some use cases when you use trees for explainability?
So that's an excellent question. So the number one use case for trees and explainability is business. And so in a previous career, I would spend a lot of time going to customers, usually with somebody from the sales team. And often we were helping folks with machine learning. We would usually display a decision tree so we could communicate what our model was doing to people who weren't necessarily developers. So maybe there was like a CEO, or maybe there was someone from the marketing department. And this was before everybody knew about ML, and we could clearly explain what our model was doing. So the number one use case is communication. And if it turns out that you ultimately decide to train a different model, like a neural network, that's great. But you can still use the decision tree to help other people at your company understand at a high level, what machine learning is and what it can do. And along those lines too, you can also use a decision tree the uh, to translate your model into business logic. So a simple example would be like again, like sometimes the business problems are boring, but they're important. So like an important problem is churn prediction. Maybe you have a lot of customers and you want to use machine learning to identify when your customer might leave your business. And maybe if you look at the decision tree, it might be, well, if the customer is reducing spend, if the customer has purchased fewer products recently, if the customer hasn't logged into your website much. And you can see these things in the tree. And it's incredibly valuable. So yeah, trees are good for communication.
Well, that's awesome. So, thank you for the answer. Also, I wanted to ask. So, for example, I understand that trees are very valuable, like from business perspective, because they can explain what's going on. But also, like, how much of decision trees or like tree-based models is it used, like inside of Google? Because, like, well, I would imagine Google has a lot of resources and a lot of data it has to process. So, like, how practical are tree models on like a huge scale inside of Google?
They're very practical. So using distributed training, you can train trees on data sets of hundreds of billions of examples. So they scale up very well.
Okay, thank you for your answer. So we also have a comment that facets looks really nice, and I agree. I actually found about facets from Josh when we were speaking, so I think it's pretty cool. Also, we have another question. How much AutoML is involved there out of the box?
Oh, I forgot. Thank you for mentioning AutoML. So I should have mentioned hyperparameter tuning, which I forgot to do. AutoML, to my knowledge, isn't used too much with tree-based models, and this is actually a good thing. So the reason you have things like AutoML with neural networks is there's 50 million hyperparameters to configure. You know, how many layers, what's the learning rate, what type of activation function, what's the arrangement of the layers, and you're basically doing a search through this huge space. When you have something like a random forest, there are parameters that you can tune, but there's far fewer and they're simpler. So that's why AutoML, to my knowledge, although I'm happy to be wrong, is generally not used for training tree-based models. Basically, you don't need it because you just use the random forest and then you move on to the next problem. But if you do want to tune hyperparameters, you can use Keras Tuner well, actually, you can use this with whatever library you want. You can use it with scikit-learn, you can use it with neural networks, or you could use it with TensorFlow Decision Forests. But it's a really nice utility from the Keras team, who are extremely helpful as always. And basically, it's a little hyperparameter tuner. So this is an example for a neural network. You're defining a sequential model, which is a stack of layers. Here we're adding 2 layers, and we're saying for this layer, we're not sure how many neurons we would like in the layer. And you can basically, what Keras Tuner will do is it will train that model with all the possibilities, and it'll basically let you know which one is most accurate. And it can do fancy things too. So basically, here's something I don't know about. So with hyperparameter tuning, there's different ways to do the tuning. You can use a grid search, which basically means try everything. You can try a random search, which I don't want to go into, but that can be more efficient. Or you can use this like fancy Bayesian hyperband statisticy. There's a yeah, it you or you can use a hyperband Bayesian something or other. So it has like our friends who are like statisticians have smarter ways to search through the space, which Keras Tuner can do for you. So anyway, you can use that to optimize the parameters for your decision forests, but you don't need AutoML.
Well, that's a very extensive answer. I actually didn't hear about Kara's team doing that. I will be happy to check it out after this speech. So I think we have time for one more question, and it's are there any special differences when putting TFDF into production? I think it's probably meant about like sklearn library or something like this.
So that's a great question. And by the way, like again, to be clear, like we're not I am no way trying to compete with libraries like sklearn or XGBoost. They're excellent. But basically, if you do want to serve your models, the primary reason I think to use TensorFlow Decision Forests, if you are already solving business problems either at your company or other companies using neural networks in TensorFlow or Keras or anything like that, you already have something set up like TF serving, or you're serving models in Google Cloud Platform. What's nice about TensorFlow Decision Forests is basically when you save your model, you get a TensorFlow saved model, which you can serve in exactly the same way as a neural network with any of these tools. So basically, it gives you like an easy avenue into production, or an easier avenue than you would otherwise have to take. And that's the
Awesome.
main reason.
Well, sometimes it is very useful to switch from neural network and just have like a tree because, they are useful and they can bring a lot of value. So I think that's why your speech is very cool to check out to people who maybe don't know much about tree-based models or have some knowledge, but you have shared a lot of very useful, interesting tools, and thank you for that. So. Thank you so much for being our speaker. That was Josh Garden. And I think, well, hopefully we're going to see each other on one of the offline events in a few years. So have a good day. Thanks for joining.
Absolutely. Thanks again. Okay. Bye-bye.
Bye bye.